Learners, welcome back to Learner Aptitude channel. Hope you are safe and healthy in this pandemic situation. First and foremost thing, if you are watching our video for the first time, please subscribe our channel by clicking subscribe button and hit the bell icon to get notified about our channel videos. By the way, my name is Ashwant and I am your guide. Now let's get started with the second part of number system, that is divisibility rules. Before going to the topic, let me tell you one important thing, that is please note down the definitions, example problems whichever taught or here. Now divisibility rules. Divisibility rule of 2. The number is divisible by 2 if and only if the unit digit is divisible by 2. For example, 556. Let's take number 556. Its unit digit is 6. It is divisible by 2 and therefore 556 is divisible by 2. While the number 555 is not divisible by 2 since its unit digit 5 is not divisible by 2. And we can say that all even numbers are divisible by 2. Next, the divisibility rule of 4. A number is divisible by 4 only when its last two digits divisible by 4. For example, in the number 284, its last two digits, that is 84, is divisible by 4 and therefore 284 is divisible by 4. And we can say that here for 4, a number with its last two digits with zeros can also divisible by 4 always. For example, let's take 200. It has unit digit as zeros. So therefore 4 can divide 200. Let's take other number, that is 34300. In this number, its last two digits are zeros, so therefore the whole number is divisible by 4. And next, divisibility rule of 8. A number is divisible by 8 only when its last three digits is divisible by 8. For example, in the number 3248 is divisible by 8 since 248, which are last three digits of the number, is divisible by 8 and therefore 3248 is divisible by 8. And we can say that here for 8, a number with its last three digits with zeros can always divisible by 8. For example, 2000. Here it has last three digits as zeros, so 2000 is divisible by 8. And next, let's see some problems related to the previous topic. Check whether the following numbers are divisible by 2, 4 or 8. Let's take the first number, that is 7. As 7 is an odd number, we know that a number which is even is always divisible by even numbers. An odd number is not divisible by an even number. And here 2, 4, 8 are even numbers, 7 is an odd number. So therefore we can say that 7 is not divisible by none of them. Next, 24. Let's take 24. Its unit digit is 4. So it is divisible by 2 and therefore 24 is divisible by 2. Next, let's take for 4. Since it has only 2 digits, so we can just multiply or just divide the number with the 4. We will get the remainder as 0, so therefore 24 is divisible by 4 as well. And next, 8. As it has only 2 digits, so we can just simply divide the number with 8 and we get the remainder as 0, so therefore we can say that 24 is also divisible by 8. And next 500. 500, its unit digit is 0, so it is divisible by 2 and the whole number is divisible by 2. Next 4. Since it has two digits as zeros, as we have discussed, 500 is divisible by 4. Next, since it has 3 digits, just we can divide the number with 8 and we get 8. 500 divided by 8. 8 6 are 48 and we get 2. Next 0 down and 8 to 16 we get remainder as 4. So therefore 500 is not divisible by 8. Next 384. Its unit digit is 4 and it is divisible by 2. So therefore the whole number is divisible by 2. Next we take 4. We know the divisibility rule of 4, that is we have to consider the last two digits. As its last two digits are divisible by 4, that is 21. So 384 is divisible by 4. Next 8. Let's check for 8. As it has only 3 digits, we can just divide the number with 8. And let's check it. 384 divided by 8. And 8 fours are 32. And we get 4 down. 6. 8 8 is 64. And we get the remainder as 0. So therefore 384 is also divisible by 8. Next we take 2468. Since it has unit digit 8 which is divisible by 2, so therefore the whole number is divisible by 2. Next we check for 4. We know the divisibility rule of 4, that is we have to consider the last two digits. As its last two digits are divisible by 4, so therefore the whole number is divisible by 4. Next we consider the 8. As per the divisibility rule of 8, we have to consider the last three digits, that is 468. We will check it whether 468 can be divisible by 8 or not. As 8 5 is 40 and we get 8 downward, 6, 8 8 is 64 and we get remainder as 4. So therefore 2468 is not divisible by 8. Next, we consider 53,720. Since it has unit digit 0 which is divisible by 2, so therefore the whole number is divisible by 2. Next, we consider the 4. As per divisibility rule, we have to consider the last two digits which is 20. 20 is divisible by 4 and therefore the whole number is divisible by 4. Next, we consider 8. As per divisibility rule of 8, we have to consider the last three digits, whether we will check it. 720 is divisible by 8 or not. 8 nines are 722 and 0. We get 0 downwards and 0. We get remainder as 0. So we can take that 53,720 is divisible by 8 as well. From these observations, we can say that the numbers which are divisible by all these numbers, that is 248, are 24, 384, 720, 53,720, and that's it. Next, we go to the divisibility rule of 3. A number is divisible by 3 only when the sum of its digits divisible by 3. For example, in the number 297, the sum of its digits, that is 2 plus 9 plus 7, is equal to 18, which is divisible by 3, then the whole number is divisible by 3 itself. Next, The divisibility rule of 9. A number is divisible by 9 only when the sum of its digits divisible by 9. For example, in the number 297, again we consider the 297, which the sum of its digit is equal to 18, which is divisible by 9, and therefore, as per the divisibility rule, 297 is divisible by 9. And we see the problems related to the previous topic. Check whether the following numbers are divisible by 3 or 9 or both. Let's consider the first number, that is 63. We know that the sum of its digit is 9. 9 is divisible by 3 as well as 9. So therefore 63 is divisible by 3 and as well as 9. Next, we consider the number 846. Now we will find the sum of its digits, that is equal to 8 plus 4 plus 6 is equal to 18, which is divisible by 3 as well as 9. So therefore this whole number is divisible by 3 and 9. Next, we consider the number 420, where its sum is equal to 4 plus 2 plus 0 is equal to 6, which is divisible by 3 only, and the whole number is divisible by 3 but not 9, as 6 is not divisible by 9. Next, we consider the number 8625, and its sum of its digits is equal to 8 plus 6 plus 2 plus 5 is equal to 21, as 21 is divisible by 3 but not 9. So this number is divisible by 3 and not 9. Next, let's consider 593. Its sum of its digits is equal to 5 plus 9 plus 3, that is equal to 17, which is not divisible by none of these numbers. So 593 is not divisible by 3 and 9 as well. And next, the numbers which are divisible by both the numbers 3 and 9 is 63 and 846. Let's discuss the divisibility rule of 5. A number is divisible by 5 only when its unit digit is either 5 or 0. For example, we consider the number 23,465. Its unit digit is 5, which is divisible by 5. So 23,465 is divisible by 5. Next, the divisibility rule of 25. The number is divisible by 25 only when its last two digits are divisible by 25. For example, 1275, we consider the number. Its last two digits, that is 75, is divisible by 25. So therefore 1275 is divisible by 25. And next, the divisibility rule of 10. A number is divisible by 10 only when its unit digit is 0. For example, let's consider the number 23,450. It has unit digit as 0, so it is divisible by 10 and the whole number is divisible by 10. Next, let's see some problems related to the previous topic. Check whether the following numbers are divisible by 5, 10 or 25. Let's consider the first number 420. Its unit digit is 0, so it is definitely divisible by 5 and 10. And next we have to check for 25. The last two digits, that is 20, is not divisible by 25, so therefore 420 is not divisible by 25. Next, we consider the number 862. Its unit digit is 2, so therefore 5 and 10 can't divide this number. as its unit digit is 2. Next, we consider the 25. As per the divisibility rule of 25, we have to consider the last two digits, which is 62. 62 is not divisible by 25. So therefore, 862 is not divisible by 25 as well. Next, let's consider the number 595. Its unit digit is 5, and therefore we can say that it is divisible by 5, and its unit digit is not 0, so we can say that it is not divisible by 10. And next, we have to check for 25. As per the divisibility rule of 25, we have to consider the last two digits, that is 95, which is not divisible by 25. Therefore, 595 is not divisible by 25 as well. Let's consider 625. Its unit digit is 5, so we can say that it is divisible by 5 but not 10. And next, we have to consider the 25. As per the divisibility rule of 25, we have to take the last two digits, which is 25. 25 is divisible by 25, so therefore 625 is divisible by 25. Let's consider 8200. Since its unit digit is 0, so it's divisible by 5 and 10 as well. And in this number, last two digits are 0, so therefore, as per the divisibility rule of 25, 8200 is also divisible by 25. And now, let's discuss the divisibility rule of 11. A number is divisible by 11 if the difference between the sum of its digits at odd places and the sum of its digits at even places is either 0 or a number divisible by 11. For example, in the number 1234, we have to start placing of the digits from right side. So 4 and 2 is in the odd places and 3 and 1 will be the even places. So sum of its digits at even odd places, that is 4 plus 2, minus sum of its digits at even places, that is 3 plus 1, that is equal to 6 minus 4, that is equal to 2, which is not divisible by 11. So therefore 1234 is not divisible by 11. Next, divisibility rule of 7 or 13. Divide the number into groups of 3 digits starting from right and find the difference between the sum of its digits at odd and even places is either 0 or divisible by 7 or 13. Then it is divisible by 7 or 13. This rule is applicable for both the numbers. For example, in the number 2345, when we start placing of the digits, we will get that 5 and 3 will be the odd places and 2 and 4 will be in the even places. That is 5 plus 3 minus 4 plus 2, that is equal to 8 minus 6 is equal to 2. 2 is not divisible by 7 or 13. So therefore 2345 is not divisible by 7 or 13. And next, let's see some problems related to the previous topic. Check whether the following numbers are divisible by 7, 11 or 13. Now let's consider the first number 336. While placing of the digits, we get that 3 and 6 be the odd places and 3 will be in the even place. That is 6 plus 3 minus 3 is equal to 6. 6 is not divisible by 7, 11 or 13, and therefore we can say that 336 is not divisible by 7, nor 11, nor 13. Let's consider 1331, and while placing we will get that 1 and 3 in the odd places and 1 and 3 in the even places. That is equal to 1 plus 3 minus 1 plus 3, that is equal to 0. We know that 0 is always divisible by all the numbers. So therefore 1331 is divisible by 7, 11 and 13. Next we consider 910. That is, while placing of the digits, we get that 0 and 9 will be in odd places, 1 will be in even places. That is equal to 0 plus 9 minus 1 is equal to 8, which is not divisible by 7, nor 11, nor 13. So therefore 910 is not divisible by these numbers. And next we consider 143. While placing of the digits of 143, we get 1 and 3 in the odd places, 4 will be in the even places. That is equal to 3 plus 1 minus 4 is equal to 0. As we know that 0 is always divisible by all the numbers, so therefore 143 is divisible by 7, 11 and 13. Next, we consider the number 10,010. That is, while placing of the digits, we get that 0, 0 and 1 will be in the odd places, and this 0, 1 will be at even places. That is equal to 0 plus 1 minus 1 plus 0. That is equal to 0, and therefore we can say that 10,010 is always divisible by 7, 11 and 13. Next, we are providing you an extra topic, that is note: if a number is divisible by p as well as q, where p and q are co-primes, then the given number is divisible by pq. If p and q are not co-primes, then the given number need not be divisible by pq, even when it is divisible by both p and q. For example, let's take a number 36. 36 is divisible by 6 and 4, but it is not divisible by 34 since 4 and 6 are not co-primes. Let's consider another example. Another example, 96. 96 is divisible by 4 and 16, but it is not divisible by 64, which is a product of 4 and 16, as 4 and 16 are not co-primes. Now you get understood. Let's see some problems, previously discussed topics. The first question, a greatest 4-digit number. We know that 9999 is the greatest 4-digit number, which is divisible by 2 and 3. Here they say that the number should be divided by 2 and 3 as well. So 2 can only divide the even numbers. So we can say that 9998 is the only even 4-digit number with greatest value, and the number should also be divisible by 3. Let's check it. 9 plus 9 plus 9 plus 8 is equal to 35, as 35 is not divided by 3, so therefore we can say that 9998 is not the greatest 4-digit number which is divisible by 2 and as well as 3. Let's consider another even greatest 4-digit number, that is 9996. Here it is divisible by 2, and let's check for 3. 9 plus 9 plus 9 plus 6 is equal to 33. which is divisible by 3. So therefore, this is the greatest 4-digit number which is divisible by 2 and as well as 3. Next, we go to the second question. A 3-digit number 4A3 is added to 984 to give the 4-digit number, that is 13B7, which is divisible by 11. Then we have to find the value of A plus B. Now I will consider this statement, that is 13B7 is divisible by 11. As a number is divisible by 11, then the difference of them, the sum of the digits at odd places and at even places, is divisible by 11. So therefore, we check it. As per placing of the digits, we will get that 7 and 3 in the odd places, 1 and b in the even places. That is equal to 7 plus 3 minus b plus 1. That is equal to 10 minus b minus 1. That is equal to 9 minus b. As the number is 9 minus b and also divisible by 11. The only number which is less than 9 and divisible by 11, that is equal to 0. So 9 minus b is equal to 0. So b is equal to 9. Now we got the value of 9. And let's consider the other statement, that is 4A3 is added to the 3-digit number 984 to give 13B7, that is 4A3 plus 984 gives 13B7, that is equal to, we have to add 4 plus 3 is 7, 8 plus a, let's consider 8 plus a as a single digit, and next 4 plus 9 is 13, that is equal to 13B7. As per similarity, here ones digit is 7 and here also 7, and here hundreds digit is 3 and here as well 3. Next, here thousands digit is also same, so we can say that each 10 digit will be also be equal. So 8 plus a is equal to b, that is equal to 9. Then a is equal to 1. So we got the values a and b. Let's add them. A plus b is equal to 1 plus 9, that is equal to 10. So the answer is equal to 10. Let's go to the third question. Which of the following numbers is not divisible by 18? As it means that 18 is equal to 9 into 2. The numbers should not be divisible by 9 and as well as 2. The numbers which are not divisible by 2 are odd numbers. Here in the options we have only the number with odd unit digit, that is D. So we can simply take the option D. Next, we go to the fourth question. If m and n are integers divisible by 5, then which of the following is not necessarily true? Then, as m and n are integers divisible by 5, we can write it as m is equal to 5x and n is equal to 5y. X and y can be any value. And next, let's check the options. M plus n, that is 5x plus 5, that is equal to 5 of x plus y, which is not necessarily divisible by 10. So A is the option. And let's check the other options as well to get more clarity. M minus n, that is 5x minus 5y, that is equal to 5 of x minus y. As it has 5 as a factor in this, so it is definitely divisible by 5. So P is the correct option. So do we know D? It is necessarily true. Next, let's consider C option. M square minus n square, that is 5x whole square minus 5y whole square, that is equal to 25x square minus 25y square. That is equal to 25 of x square minus y square. As it has 25 as a factor, it is definitely divisible by 25. So C is also not the option we want. So therefore A is only the option which is not necessarily true. Next, let's go to the fifth question. An integer divisible by 16 if and only if its last x digits are divisible by 16. Then x is equal to. Now let's check. Let's take the logic. For example, the divisibility rule of 4 is the number with its last two digits should be divisible by 4, then the number is divisible by 4. And next, divisibility rule of 8. The number with its last three digits divisible by 8, then the whole number is divisible by 8. So, with the logic, we can say that for 16, the divisibility rule of 16 is nothing but the number with its last 4 digits divisible by 16, then the whole number is divisible by 16. So, with the logic, we can tick the option B. Sometimes logic may work in the aptitude. Next, for the sixth question. For the number, this check the divisibility by 3 and 11. First, I'll check the divisibility rule for 3. Now, as per divisibility rule of 3, the number whose sum of its digits is divisible by 3, then the whole number is divisible by 3. Now let's check this number. When we add the digits, we get 35, which is not divisible by 3, then the whole number is not divisible by 3. And next, let's check for 11. As per the divisibility rule of 11, the number whose difference of sum of its digits at odd places and at even places is divisible by 11, then the whole number is divisible by 11. Let's check for this number. Now let's subtract the digits at odd places minus the digits at even places. Then we get that 3. As 3 is not divisible by 11, so we can say that the whole number is not divisible by 11 as well as 3. Next, let's go to the seventh question. If n be any natural number, then by which largest number n cube minus n is always divisible? Let's substitute the natural numbers and we can get it. For the first natural number, that is 1, we substitute, then 1 cube minus 1 is equal to 0. We know that 0 is also divisible by all the numbers. Next, we consider the natural number 2. 2 cube minus 2 is equal to 8 minus 2, that is equal to 6. 6 is divisible by 3 as well as 6. Let's consider the 3 natural number. Then 3 cube minus 3 is equal to 27 minus 3, that is equal to 24. 24 is also divisible by 3, 6 and 12. So we can say that 3 and 6 are the numbers which always divides n cube minus n. So therefore A and B are the correct options. Next. So in the next video, we will be discussing the remaining topics and problems from number system. Thank you for watching our video. Please give your valuable feedback, ideas or queries in the comment section, and also please like, share and subscribe our channel Learner Aptitude